Thank you very much. Here I want to just give a brief overview of my research. Recently, my research covers several topics, and I'm mainly focused on the first one, multi-agent system. Briefly, for the identification of dynamic system, it's really you get the system. You want to get the input and output, and then to determine the structure of the system. And normally, we have to make some assumption about the system, focus on linear, and also we can also consider nonlinear system. Then, but your measurement for the input and output may corrupt by noise, and also in the presence of the controller in the system. So in that case, consider identification of the system. For the network control system, that means you want to control system through the communication channel, because you remotely you want to send your control signal to control signal through the feedback. But then, due to the communication channel constraint, you have the data drops and also some noise. So then you can need to consider that kind of the disturbances. And for the blind signal processing, we consider identify the system in the communication system, identify the system with the output only, without knowing the input. Right? But in this case, we have to put some constraint on this input system, on the system. And the other part about the neural network, we consider multi-stabilities. Then we consider how many equilibrium points of the system can have. We want to have as many as possible, so when we can, because in the image processing, those equilibrium points can be used to restore the images. Then later can recover later. Now I want to focus on the first topic about this multi-agent system. Start with some natural phenomena. For example, we consider this fishes swarming. In this case, swarm can move together in groups. In this nice picture, it shows the fish moving in the swarm. The other thing we consider is bird flocking. And in this case, birds are just want to congregate or travel in flocks. This is another phenomenon we observe. Then this comes to the consensus issue. They say that in some military field management scenario, then you can want to control this fly to attack this target, or this fly fly in a certain formation. Right? In this case, that means the purpose you want to make the group of the mobile agents to reach the same position. So this is we're talking about the consensus. And some other area of this multi-agent system considered is the fly synchronization in the firework at the New Year Eve and some other celebrating events. And also this attitude is the alignment. You will consider this attitude of each spacecraft will be synchronized in a certain range, in certain position. And what in common in this all these phenomena is that we have to deal with some agent, and there will be the network. But when you want to reach some purpose, you need to have this add some control. But then your control will be based on the distributed control. That means each agent is going to communicate with the neighbors only, and then the final person reach the global consensus. In the model of this kind of system, normally, actually, I start with a simple example here. We consider using this first order, this linear differential equation to describe the agent, right? And then we have this Gij used to derive the weight, this directed edge from the one node to another node. And what we mean by this consensus mathematically means that when t goes to infinity, these two edge state of these two agencies will approach to zero. This will go to zero. Right? So essentially, that means that will reach the synchronized. And in terms of graph theory, this consensus is achieved. The sufficient necessary condition will be that the network contains directed spanning tree. This is pure proof. Okay. In my recent research, we look at this bipartite consensus. That means you have the two pole bodies. That means they just compete each other. Sometimes they cooperate, but sometimes they compete each other. here I put the picture here, and like in Australia, we have the liberal correlation. They have sometimes some policies they have to cooperate. Some cases they have to compete with each other. In this case, we have the problem is formulated as these two groups. That means they sometimes we consider they are hostile agency, but they have the limited cooperation, right? Then in this case, biparty consensus, that means when t goes to infinity, one group will go to reach this consensus C, the other goes to reach the opposite value. And so our purpose is want to modify the interconnection of the network and also model the agent dynamics. We use a graph theory. This is just graph, a simple graph. We use a V set of V is the node, set of nodes, and then E is the edge, and then it's a adjacent matrix for the connection between edges. And then we can have this graph using this spanning tree to describe this graph between the connection. And we consider simple case using this first order differential equation. Then our purpose to design this UI so that we can reach the biparty consensus. And it turns out this control law is quite simple, and we use the sign function and use the interaction between the next levels. We'll have this one. This will be in the end in the matrix form we have used the signed Laplacian matrix to describe with our control system. I'll show you quick example here. We have the two scenarios with this different eigenvalue. Those two things reduce the problem of this eigenvalue of this Laplacian matrix. So we have this simulation. You can see on this control we have to reach the two biparty control. This biparty consensus. This for the second and third. First and second is the networks. There are some recent publication about this result, published in recent paper, just listed here. Next one is the reference. My colleague reference asked me to mention his work. Actually, Andy already mentioned in the beginning, so I just already into the slide. He published the paper in the edited book. Detail title is small. The book he collaborated with first from the Sydney University. And he also will be invited to give talk at the